way to take charge, Josh. All right, so the question is the inverse of the logistic function a function, why or why not? Well, I think it probably behooves us to draw or at least visualize the logistic function, right? There it is. If we want to know if it's a function, we do the vertical line test, right? But if we want to know if its inverse is a function, we do the horizontal line test. So, if you just imagine or physically draw in horizontal lines, do any of the horizontal lines intersect this curve in more than one place? No. No. So the answer is yes, the inverse is a function because there she is. The logistic function passes the horizontal line test. Jacob, does that answer your question?
Yeah, I guess I got confused because of those lines.
All right, read.
Number 2.
Number 2?
Yeah.
Says eliminate the parameter and write a single Cartesian equation. So we want to end up with one equation that has nothing like x's and y's in it. So that means we have to get rid of the t.
Yeah.
So you got a couple of options. One option is to just solve for t and then plug that in. So you have x equals 6 minus 3 times y minus 5. So 6 minus 3y plus 15, negative 3y plus 21, and we would probably write that x plus 3y equals 21 since it's a line and that's the standard formula line.
Okay.
Some of you wrote the line in slope-intercept form, and that's fine too. That's fine too. You didn't need to do that, but that's fine. Some of you didn't, I use substitution here. Some of you didn't substitute, some of you eliminated. So if we rewrite that y equation as 5 plus t, you can see if you multiply it by 3, the t's will cancel out. So that'll work too, elimination. All right, Ollie?
4C.
4C. See, there are two things happening. What are the two things happening in that problem? What does the negative here do? Yes, so that's a reflection across the y-axis. And what does this guy do right here? Down 1. So we'll do that. I'll do that in a couple of steps. Some of you can probably do it in one. I'm going to do it in 2 steps. Always start in the parentheses first. So I got my original picture, and I'm just going to go ahead and not draw the original. I'm just going to start by reflecting the original across the y-axis. So the triangle in the original that's down here is going to come over here. And then the triangle that's originally on the right, or the left, the taller triangle on the left is going to be over here. And so is the shorter one. So there is my picture reflected across the y-axis. Now I'll take that thing and move it down 1. So it's easier on the grid to do that, but so the blue would be the answer. All right, anybody else have a question about one of the things? Okay, let's put those away then. And I can't remember what day it was, but one day I gave you some review materials. I would like you to find those, particularly the sheet, and this might be stapled in some kind of packet or something, but find the sheet that says Precal A, Extra Practice 1.7. It says Precal A, Extra Practice 1.7. It's a single sheet, but it has a front and a back. Find it?
Yeah, I think so. Extra practice.
Yep, extra practice. No. This one just says extra practice 1.7. Yes. We're going to work on that one later, but right now it says extra practice 1.7. All right, so here we go. Number one. Sign out. Number one. Find the dimensions of the largest box that can be created from a 12 by 15 sheet of paper if square corners are removed and the resulting flaps are folded up. So we know what to do, right? Caution about this though, the question is find the dimensions. So when we get to the end of the problem, we want to make sure that's what we put down. Before we did maximum volume, but this time it wants the dimensions, but it's the same problem. So our piece of paper is 12 by 15. We're cutting out the corners, folding up the flaps. What's X going to stand for? I need an X. What's X? Yeah, how big are these? I mean, that's X, right? I want to know how big to cut out, the corners to cut out. So what does my volume equation look like? I'm going to maximize the volume. So I need an equation for the volume. What will that look like? 15 Yep. And of course the order of those doesn't make any difference. That's the volume. Length times width times height, right? What's my domain? I'm going to graph this in a minute on my calculator, and I want to make sure I'm looking at the right part of the graph. Okay, this is a curving line. You want to make sure you're looking at the right part of it when you go to find your maximum. So where are my x's? My x's are going to be between what and what? They're going to be between 0 and 6. Always positive. And then where did the 6 come from? Half the smaller. Right. So, as an interval, that would be written like this. That's the open interval from 1 to 6. That represents all the x's from 0 to 6. I mean 0 to 6. All right, so let's go ahead and put that in our calculator and graph it. Make sure you make whatever window adjustments are necessary. Okay, you see a hill? Looks about like all the other hills we've been looking at, right? So let's find our maximum, and remember it's going to come up as a point, an x and a y. I got 2.209 and 177.234. Does anyone match that? Okay, so now let's answer the question. Find the dimensions of the box. So the dimensions will be length times width times height, right? So I know my height already. Isn't my height x? Holding up the flats, the height is x. So I know my height's going to be 2.209. How will I find my length and width? Yeah, it's right here, isn't it? So I'll just take 15 minus 2 times that. So 15 minus 2 times 2.209. And that's 10.582. And then the other one will just be 3 less than that, so 7.582. And those are all inches. So the dimensions of my box, 10.582 by 7.582 by 2.209. And what should happen, that's the answer, those are the dimensions. But what should happen if I multiplied all three of those numbers together? What should I get if I did length times width times height? Shouldn't I get that number right there? Yeah, that might be off a little bit because of round off error, but it should be really close to that number right there. Okay, all right. Everybody good with number 1? Number 2, your take-home pay is $480 a week. And your monthly car payment is $230 a month. Okay, so this is a week. And $230 a month is what you pay. What percentage of your monthly pay is your car payment? Easy, easy, easy. How are we going to figure that out? When you grow up and you have a job and you have bills, you're going to care about this. How are you going to figure that out? Jacob?
You do the amount of percent oh wait, no. But you do the difference divided by usual.
Well, it doesn't say if this is a percent increase or decrease. I just want to know straight up, what's the percentage? Okay, stop. If you get 2 out of 3 right on a quiz, how do I figure your percentage?
You think
2 divided by 3. So I want to know what percentage I'm paying out. So the first thing I'm going to do is get a monthly, turn this into a monthly thing. So I'm going to take 480 times 4. What is that?
1,920.
So that's how much I make a month. And I want to know what percentage that is of it. So won't I just take 230 and divide it by 1920? Don't overthink this stuff, guys. So it's about almost 12%.
Yeah.
It's 11.979. How many ounces of Jolt with 22% caffeine should be mixed with 12 ounces of Amp, 18% caffeine, to get a beverage with 21% caffeine? Now this one, Jacob, is amount times percent. Do you see how you're mixing things together?
Yeah.
So I always write that down to kind of keep myself focused. All right, so here we go, my percentages are 22, 18, and 21. And the only other number I have is 12 12. And that goes here. Everybody okay so far? So how much, how many ounces? I'm gonna put my X there. It's my variable, that's what I'm looking for. And what's that gonna make this one on the end?
12 plus X.
12 plus X. Or X plus 12. Because I'm adding these two together to come up with this. So now I just have an equation to solve. I can use my calculator to help me. Multiplication. Oops. Distributed over here on this side. Wish I had a nickel for every time this mistake is made. When we move this over to here, what am I gonna have left over here? What? 0.01. Don't forget that 01. It's not 1. I know 22 minus 21 is 1, but it's 0.01. Equal to, what's that gonna be? 0.36. So are you getting 36 ounces? Don't forget on a word problem to put a unit as your answer, just like here we said inches, here we're gonna say ounces. Okay? All right, Tyler bought a new sweatshirt. The original price of the sweatshirt was $36. It was on sale for 40% off, and there's a 7% tax. You gotta be real careful with round off errors. So there's my original price. The two things are happening. I am on sale, so I have a 40% discount. And I have a 7% tax. So remember, we can do this in one step and have no round off error at all. What do we multiply by if we have a... Are you quite comfortable back there? All right. 40% discount. What am I going to multiply by? 0.60. Because I'm not paying 40%, so I am paying 60%. Now, I'm adding on 7% though. So what am I going to multiply there? 1.07. 1.07. 100 plus 7. We got to pay the full amount plus an extra 7%. So that should give me my answer. Round it off to the nearest cent. And he's going to pay $23.11. Would you agree with that? Easy peasy. All right. Problem is not very good. I need you to cross out that picture and turn that cone upside down. Yeah. I need you to turn that cone upside down, otherwise I need to give you some other information that I'm not gonna mess with. So the cone, or the tank is filled to a depth of 14 feet, and the diameter is 10 feet. Okay. The liquid in the tank is draining out. What will be the volume of liquid in the tank after T seconds? Okay, well, what's the volume in the tank right now? I didn't give you a formula. So the volume in the tank right now would be what? 1/3 pi times what?
7.
7.
Times 5 squared.
Yeah, I don't know where 7 is coming from. This would be 25, 5 squared
The volume.
times
Times 14.
14. So that's how much water is in the tank right now, when it is full, right? But now we're gonna let some, and then we're gonna let some water out. Did you get 366.52? And that would be when I get my answer, I put a unit on that. Well, let's get our answer. So that's how much is in the tank right now. Now we open up the spigot, and out comes stuff at a rate of, where am I at here? 2 cubic feet per second. So I want to know what will be the volume after 2 seconds. Oh, this is easy. That's what it starts out as. We're losing some, right? How much are we losing? 2 feet per second. How many, 2 cubic feet per second. How many seconds are we letting it go for? T? So what's that gonna look like? Minus 2T. Cubic feet. That's gonna be the volume. I don't know how many seconds it's running out, but every second is worth 2, so 2T. Notice the question said, well, it doesn't say, it doesn't, never mind. That's all I can do. So if we knew it was running out for 3 seconds, we would just put a 3 in there, right? And figure it out. All right, now we got a cylindrical tank. And then we got 100 inches. And the diameter is 20 inches. And fluid is running out at 12 cubic inches per minute. What will be the volume of liquid after 2 minutes? This is exactly the same problem, except it's a cylinder. So what's my formula for the cylinder? Volume. Full cylinder will be what? Pi r squared. So r squared would be, well, r is 10, so it would be 100. And then the height is also 100. So that's the full tank. Everybody in agreement? Now how fast is it going out? 12 per minute. And I want to know how much will be in there after 2 minutes. So I'll just take this number right here, whatever 100,000 pi is, and subtract what? 12T, yep, 12T. It's coming out at 12 cubic inches per minute. I'm letting it go for T minutes, so this is how much is gonna come out. Right, 1 minute would be 12, 2 minutes would be 24. I want T minutes, so it's just 12T. Perfect. All right, now find the one that says extra practice 1.5 to 1.7. It says extra practice 1.5 to 1.7. Okay. So let's see what we've got on this one. All right, so we got a function, and we want to find its inverse. This is the sheet that says extra practice 1.5 to 1.7. All right, so we're going to find the inverse. So what are the steps to that again?
Switch the X and
Switch
Y.
the X and Y, so we'll do that first. Now we got to get Y by itself, right? You know what, if you can't find the paper, just stop and just start writing it down, okay? Because that's the important part, so we're doing it now. So now we're going to multiply and distribute. Now, this is the part where some of you are still kind of making mistakes. You are solving for what? What letter are we trying to get by itself? Y. So you have got to put the Y's on the same side. You cannot get Y by itself if they're not on the same side. So here we go. I'm going to rearrange my terms. And it's always, in this kind of problem, it's always these two that end up switching. Just switching places. Now you can take that Y out. And then we can divide. So there's our inverse. Now, in the beginning, the original problem, right here, we have a vertical asymptote where? Where's gonna be your vertical asymptote?
2/3.
Negative 2/3. So your domain, you have a vertical asymptote at negative 2/3. So your domain is everything except negative 2/3, right? Where is the horizontal asymptote for this function? 4/3, y equals 4/3. So your range would be everything except 4/3. You got a horizontal asymptote running across, and so you got stuff up here and stuff down here, but 4/3 is not included. It's a horizontal asymptote. So when I do the inverse, what had better happen? Remember, you switch the variables. So for this, the vertical asymptote should be where the horizontal was before. Is the vertical asymptote here at 4/3? Yeah. And then where should your horizontal asymptote be? Should be at negative 2/3, and is it? Yep. So this is domain tied to domain and range. These are the cannot be's in your domain and range. So now the question says, what is the domain of the inverse? Well, the inverse has a vertical asymptote at 4/3, so its domain would be negative infinity to 4/3. and 4/3 to infinity, wouldn't it? Everything except 4/3. Now, what I'm trying to help you see here is, I could have answered this part of the question without doing any work at all. Because the domain of this is going to be the range of this, right? So I can look at my original problem and see I have a horizontal asymptote of 4/3, which means this vertical is going to be a 4/3. Okay. All right, number 2, prove that these two things are inverses. Now remember, it's kind of picky what constitutes the proof. Who remembers what we have to do if we are actually proving their inverses? Some of you had some trouble on your homework with this question. You build a composition. That's exactly right. So you do f of g of x, excuse me, and you do g of f of x. And when I do that, they had better come out to be x. Everything should cancel, and all I have left is x. So this says plug g into f. So I'm going to take my g function and plug it into f. So I'll have 4 times x plus 2 over 4 minus 2. This is g into f. Now, you see what's going to happen? What's going to happen with these 4's? It's gone, and we're left with x plus 2 minus 2, which is x. That's what has to happen. But you got to do it both ways. Believe it or not, there are things that are inverses one direction and not the other, so they're rare. We're going to take f of x, or f, and plug it into g. So f into g would be 4x minus 2 plus 2 over 4. That's the f function into the g function. So the 2's cancel, and then the 4's cancel, and lo and behold, we get x. That's the proof. All right, plugging one function into the other. Okay, now you've got some sketches. Okay. The original up here, let's see. So there's the original. Tell me about A. What do you think this is going to look like? What happens here? Well, bottoms up, the negative part becomes positive. So in terms of this picture, all that stays the same. Those little triangles there, they stay exactly the same. Nothing changes because they are both positive to start with. But this guy is going to have to go up. So that's this part. Is everybody okay with that? So then what happens? Gotta go up 1. So you just take the points that you've got here, and you're going to move everything up 1. And that purple thing would be your answer. All good? Okay. So then the next one says, a couple different things happening here too. Tell me about that negative there. What does that negative do?
It reflects the water.
That's right. So this negative goes this way, right? So we're going to take this and draw it over here. And then we're going to take those and draw them over here. So that takes care of the flipping part. Now what does the 2 out there do?
Multiplies the water.
Multiplies the height. That's a height. Nothing is moving up or down. That's not what's happening. We're stretching it. So it's like you grab a hold of these points and pull them up twice as high as they were before. Or twice as low as they were before. So the purple one is the answer to the question. All right, what happens in the next one? 2 things happen in the next one. What's going on? What's that do? Okay, so it flips it upside down. It changes the sign on the Y. Makes the, whatever Y was, it becomes the opposite of that. So this is upside down across the x-axis, changes the sign on Y. And then what does this do? Divides the x's. The width, in other words. It divides the width of the picture. Okay? Now, don't get confused. You're dividing by this number. Dividing by 1/3 in reality is multiplying by 3. So that picture is going to be 3 times as wide. That means each of these shapes is going to be 3 times as wide. And it's going to be upside down. So let's start with this triangle right here. How wide is he? 2. Now he's going to be 6 and upside down. There he is. Upside down, 3 times as wide. Now what about that one? He's 2, so he is also going to be 6. And upside down. I'm in trouble over here, I think. How wide is this one going to be?
9.
Yep, he's going to be 9. And upside down, which means up here now. There he is. Upside down and 3 times as wide. Notice that the height didn't change. Still 2 and 1 and 3. But the width changed. All right, one more. What's this one do? Yeah, you draw the right side, so whatever I have on the right of my original, I just draw it exactly as it is. So there's the right side. And then I draw it again on the left. There it is. That's all there is to it. You draw the right and then redraw it on the left. Oh boy, look at the next one. So using this original, can you figure out what happened to get that picture in number 4? Let's see.
Was it
Has it been flipped upside down?
well, like flipped across the?
It's been flipped across the y-axis. Would everybody agree with that? So let's make a list here. We got to reflect across y. All right. What else has happened to it?
It's been moved right.
It's been moved what? Up 2? Is it 2? I think it's 2. Is that it? Does that take care of what happened? I think so. I think that takes care of it. Because if I flip it, I'll have, like this shape. And then if I pick that up 2, won't I have what I have there? I think so. So what's my equation going to look like? It reflects across the y-axis and lifts it up 2. Y equals what?
F of negative x.
F of negative x
And then
plus 2. Perfect. The negative inside is the one that takes you across the x-axis. Okay? Describing words, the transformations required to change this into this. Okay, so I want you to think about this for a second. What does F look like? This is a separate problem not tied to that one. What's the shape? It's a parabola. And where's its vertex?
negative 4. Or
Left 2 and down 4? And which way does it open? Up? Yeah, it's your regular. Negative 4. Now, is G also a parabola? Yep. But some things have happened to it. Now, its vertex is at 3, 1. And it's opening down. Would you agree with that? So now, in words, tell me what happened to get from that one to this one. Well, first you had to have a reflection across the x-axis, upside down. So you had to turn it upside down, reflect across the x-axis. All right, and then what else happened? Well, now wait, I think, all right, so let's take this one and turn it upside down. You talked about that already, to turn it upside down. If you pick that one up, flip it upside down. If you pick it up, can you paste it right on top of here? So I'm not really mirroring, I'm moving it. And how many spaces am I moving it? Well, in the x direction, we're going from negative 2 to 5 or to 3. So you're going to move it 5 units to the right. And then in the y direction, you're going from negative 4 to 1. So you're moving it 5 units up. So to get from that parabola to that parabola, you got to tip it upside down, right? And then you got to go 5 units right, 5 units up. And you'll have exactly the same picture. Okay? Jacob?
So do you reflect first, or do you go 5 units right and 5 units?
In this case, it wouldn't make any difference, because if you go 5 and 5, you're going to be sitting here with this parabola, and then you turn it upside down. So normally we would reflect first, because that's like a multiplication, and then move Normally we move right and left first, because that's inside the parentheses, and then up and down last. But in this problem, it wouldn't make any difference. All right, number 6, we've already talked about today on your quiz, but let's run through this again. Write a single equation. In terms of x and y. So in other words, eliminate the parameter. Write as a Cartesian equation, sometimes also called a rectangular equation, x and y. Alright, so here we go. Elimination's not going to work very well on this one because that's a plain t and that's a t squared. So it's going to be hard to cancel them out. So let's do substitution. Remember, I'm getting rid of t. So I got to know what t equals. So let's see, if I move that t over, I always have to be careful when I do this. Moving around in my head. Is that right? Put the t over here and move the x over here. So now that's going to get plugged in here. So y equals 1 plus 2 minus x squared. So y equals 1 plus, that's a FOIL. That's a FOIL. I'm going to start taking off extra points if you don't handle that right. That is a FOIL. Anytime you have parentheses to a power, it's a FOIL. So 4 minus 4x plus x squared. That's 2 minus x times 2 minus x. So it looks like we've got x squared minus 4x plus 5. Now, am I going to do the quadratic formula or anything like that with this? Nope. It says write the equation. So there it is. There's your equation. My allowance is $2.50 a week. I spend 49 cents on a stamp. What percent of my allowance is spent on postage? Don't make this hard. How are you going to calculate that? What are you going to do? Exactly. You're going to take 0.49 and divide it by 2.5. And that's going to give you your percentage. So about 19.6%. That's pretty pathetic, right? 20% of your weekly income is spent on one stamp. All right, how many ounces of 73% orange juice should be mixed with 20 ounces of 34% orange juice to get a 60% solution? What's going through your mind right now? Yep, amount times percent, amount times percent equals amount times percent. Okay, we're running out of time. Let's see if we can get this set up. We won't have time to solve it probably. Let's type in our percentages. So we got 73 and 34 and 60. What amount do I know? I always know one amount. Which one do I know?
20 ounces.
I know 20 ounces. And that one's going to go with the 34. I want to know how much of that I should mix in. So once again, this is on the end. I'm adding them together. So that's going to be 20 plus x. I think we have time to get that cranked out. So 0.73x plus 6.8. Have to double check that. gosh, I think this is gonna come out evenly, is that 40?
Yeah.
And then we put a unit on that, ounces. All right, quickly, we have a cylinder. So we got our cylindrical tank. And it has a 15-inch diameter. And the water in the tank is 20 inches deep. If the drain is open, it's leaving at 2.5. This sounds familiar. Write an expression for the volume of water in the tank 2 minutes after the drain is open. Okay, this is the third one of these we've done today. What is the formula for the volume of a cylinder? Pi r squared h. So we're going to take pi times 7.5 squared times 20. That's how much water is in the tank right now. Some is running out. How much is running out? 2.5 every minute or second, whatever the unit is there. We can type all that in, get a number. So 7.5 squared times 20. I'm going to go ahead and leave the pi in there. That would be the volume of water left in the tank after T minutes. All right, last question. Is the square root function 1 to 1, why or why not? Square root function 1 to 1. What's the square root function look like? Remember? Air draw it for me. Woo, no, square root, square root, square root. That's the one that looks like this. Right? Is it 1 to 1?
Yes.
Why?
Because if they cut this
Passes vertical and horizontal. Remember, 1 to 1 means you pass both tests. It means you are a function, vertical line test, and your inverse is a function, horizontal line test. Okay? All right. So the big challenge for you people is going to be, you have to remember all this stuff. Because, you don't want to already? Good job. All right, let me spray off the desk. If you don't wipe them off, I'm just going to spray them. Oh, let's turn this off.